so we have Miriam who's going to join us, and she is awesome and has a lot of experience in chemistry and is a bit of a chemistry subject matter expert. She's also got a YouTube channel I want you guys all to check out. It's called The Tutor Geek, and it's really nursing, math, and science. And I know she's got a lot of videos coming out, but I love her videos. We actually reached out to her to see if she would be interested in kind of working with Smart Edition to do these free tutoring sessions with you guys. So hopefully you guys will find some value in this.
Thanks, John.
So this evening, chemistry's got quite a few topics in it. And this evening, we're going to focus on states of matter. And everything that Miriam's going to go over is in the Smart Edition Academy online course. So she's going to share her screen and you'll be able to see it. I've got the online course pulled up here. I'll show you guys what's in there, and then I will pass it over to Miriam. She can get started. So just a quick question, if you guys can put it in the chat. I'm curious, how many people are taking the TEAS and how many are taking the HESI? This topic is on both of those tests, so just kind of curious where you guys are at. So a lot of folks, TEAS right off the bat. Okay. Cool. And then let me know how you guys are feeling about chemistry so far. A lot of subjects, people feel good and bad about, but chemistry is one that I hear over and over again that it's just something they haven't seen in a long time or really studied much at all. They may not have taken college courses on chemistry, so that's kind of difficult. So a few people saying nervous, confusing. So hopefully we can add some clarity to this. Someone says they suck at chem. That's okay. Three cry face emojis. I feel you on that one. Scared. Okay, does anybody feel good about chemistry? Nobody. Okay, good. Well, it seems like we have a good room here of folks who don't like it. Okay. So nobody has anything good to say about chemistry except for Miriam.
Welcome, everybody. I'm excited to be here. And today we're going to do states of matter, which is pretty much an intro into chem. And if you guys have any questions or I'm going too fast, please slow me down. Please let me know, okay, in the chat. Alrighty, so let's get started. I'm going to go ahead and share screen. So this lesson explains the differences between solids, liquids, gases, and plasma. It also describes how a sample can change from one state of matter to another state of matter. This is what we call state of matter changes. On Earth, substances are found in 4 states of matter: solid, liquid, gas, and plasma. Many properties of these states of matter are familiar. For example, solids are rigid and hard, liquids can float inside their containers, and gases can spread throughout the entire room. But what happens at the molecular level may not be as familiar. The differences among them can be explained by the amount of energy that the particles have and the strength of the cohesive forces that hold the particles together. Cohesion, let me zoom in here so you guys can see the definition. Cohesion is the tendency of particles of the same kind to stick to each other and is an important property to consider when looking at the states of matter. So cohesion, that's going to be a very high yield chemistry terminology. So you definitely want to write that one down. The motion and density of particles in a substance and the tendency of a substance to take up the shape and volume of its container differentiate states of matter. So solids have the lowest energy. The particles are packed closely together and their structure is relatively rigid. So rigid, you can think of something like a desk. It's solid, it's packed together. Strong cohesive forces prevent particles from moving very far or very fast. Therefore, both the shape and volume of solids are very fixed. And this is very important for solids, is that the shape and the volume are fixed. They're constant, they're not changing. In liquids, particles have more energy than in solids and can overcome the cohesion forces to some degree. Since particles can move more freely, they flow and take the shape of their container. However, cohesive forces are strong enough to somewhat restrict the movement of particles. While the shape of the liquid is not fixed, the volume is. So for a liquid, they have more energy than a solid, but they have less energy than a gas, and they have for while the shape of the liquid is not fixed, the volume is fixed or constant. Gases have more energy than solids or liquids. In a gas, the cohesive forces are very weak because the particles move very quickly. Gas particles move more freely than liquids, which means that gas particles can not only take the shape of the container, but also spread to occupy the entire volume of the container. In other words, gases take the volume and shape of the container that they are in. And gases have more energy than liquids and solids.
Does that make sense for everybody?
Yes.
Yes.
Okay, so basically 3 major things from solids, liquids, and gas. You just need to know the energy and the volume and the shape if it's fixed. So for plasma, in plasma, the particles have so much energy that the electrons separate from their nuclei. The result is a substance composed of moving positively and negatively charged particles. Although plasma are less common in everyday life than the other states of matter, there are a few very familiar examples. First, the hottest part of the sun are made of plasma because of the high temperatures. Also, neon signs glow when plasma is produced by passing an electric current through a gas. So we have a question here. In which state of matter are particles moving the slowest? Do we have any?
Yeah, Miriam, before you answer that, why don't everybody go ahead and put your answers in the chat, and we'll see what everybody says. A lot of people saying solid, so I think we're on to the right thing here, and everybody seems to be in agreement here. Let's see, and it is.
Awesome. So so solids have the slowest moving because they have the less energy than particles in other states of matter. And they also have the strongest intermolecular or cohesive forces. It's basically the glue that holds 2 molecules together. It's basically what makes solids like so rigid and stiff. So.
Okay, cool.
Okay, so next we have phase changes. Let me try and zoom in a bit more. Whenever a substance transforms from one state of matter to another, it undergoes a phase change. These processes are physical changes because the chemical composition of the substance remains the same, only its appearance is different. The 6 most common phase changes are summarized in the diagram below. Note that the state of matter are arranged in order of increasing energy from left to right. So these pretty much correlate with this chart right here. Solid, you're going to have the least amount of energy. As you go from a solid to liquid, the energy is going to increase. And as you go from a liquid to a gas, the energy is also going to increase. And as you go from a solid to a gas, sublimation, energy is also going to increase. Does that make any sense? How the energy is kind of correlated?
Yeah, it looks good. I think everybody's got a yes on that. So, and again, if you guys have questions, drop them in the chat, or you can use the hand icon to raise your hand, and we can unmute you, and you can ask any questions that you might have.
Okay, so these are the phase changes, and this basically just tells if going from one phase change to another, if it's absorbing energy or releasing energy. So solid to a liquid, during melting, you're absorbing. Liquid to a gas, which is vaporization, absorbing. Solid to a gas, during sublimation, also absorbing. Liquid to a solid, freezing, you're releasing energy. Gas to a liquid, condensation, you're releasing. And gas to a solid, deposition, also you're releasing energy. So all phase changes require the system to either absorb or release energy. Any phase changes that move to the right in the diagram above require energy to be added to the system because the substance has more energy at the end of the phase than in the beginning. The phase changes are melting, vaporization, or boiling, and sublimation. When energy is added, particles move faster and can break away from each other more easily as they move to one state of matter with a higher amount of energy. This is most commonly done by heating the substance. Any phase change that moves to the left of the diagram requires energy to be removed from the system because the substance has less energy at the end of the phase. These phase changes are freezing, condensation, and deposition. When the particles release energy, they move more slowly. The cohesive forces bring these particles closer together as they move to a state of matter with a lower amount of energy. This is most commonly done by cooling the substance. So the temperature at which phase changes occur depends on the strength of the cohesive forces between the particles. For substances like metals that have high melting points and high boiling points, it takes a relatively large amount of energy to overcome the intermolecular forces enough to change the states of matter. Similarly, substances with low melting and boiling points, like the gas that make up the Earth's atmosphere, do not require as much energy to overcome the intermolecular forces. So we have a question here. Which of the following phase changes require a substance to release energy?
Condensation.
Mm-hmm.
What do you guys think? Condensation. We've got a couple condensations. That is the correct answer.
So yeah, condensation, we're going to be releasing energy. A gas turns to a liquid, and for this to occur, high energy particles in a gas must release some energy for the cohesive forces to bring the particles closer together. Here is a really good graph of a heating and cooling curve. When studying phase changes, one can examine the heating and cooling curve of a substance. Heating and cooling curves are plots of temperature versus time that occurs as energy is added to or removed from the system at a constant rate. So you'll notice that for the heating curve, it's always going to start at the bottom and steadily increase to the right. And for the cooling curve, it's always going to do the opposite. It's going to start to the left and decrease to the right. The heating curve for water is shown above. Notice that at the beginning of the experiment, the substance is a solid. As heat is added, the temperature of the solid increases until it reaches its melting point, 0 degrees Celsius. The temperature remains constant at the melting point until the entire sample has changed to a liquid. Note that even though heat is still being added, the temperature is not increasing. This is because the added energy is used to disrupt the cohesive forces in the solid, allowing the particles to move more freely as the substance changes to a liquid. Once the sample is completely melted, the temperature increases again. It increases until the boiling point, 100 degrees Celsius, is reached. Heat is still being added, but the temperature remains constant as the substance boils. This time, the added energy is being used to break the intermolecular bonds in the liquid as the particles transform into a gas and move further away from each other. It is not until the phase change is completely complete and the sample is entirely gas that the temperature starts increasing again. A cooling curve has the opposite change of heating curve as seen in the graph above. In these experiments, the sample starts as a high temperature gas. As heat is removed, the temperature of the gas decreases to its boiling point. At this point, the temperature remains constant until the entire sample is liquid. The liquid then cools to a lower temperature until it reaches a freezing point. The temperature remains constant as the substance freezes, and once again, it's completely a solid. The temperature decreases again. So if a sample of water is losing energy, but its temperature is not changing, what would be happening, or what could be happening?
All right, so what do you guys think here? Freezing, melting, vaporization, and does that say sublimation?
you guys can kind of look over here so it says the sample water is losing energy. So we would pretty much look at the, sorry?
Freezing?
Yes. At the cooling curve. So when a substance is freezing, the liquid particles lose enough energy to become a solid. The temperature will not change until the phase change is complete. So basically, when you're going through some phase changes like we see here, you'll see that the temperature, like at melting and at boiling, condensing and freezing, you'll see that the temperature is the same. It doesn't change.
Does this all make sense for you guys so far? Do you guys have any questions on any of this? So Dami has one, so I'm going to I guess Donna has one. So Donna, let me unmute you for just a second. Hold on. All right, so we had some other questions. Let's see what else we had here.
Yeah, I had a question.
Yep, go ahead.
So what would be an example of condensation in like nature?
Condensation in nature. Gas to liquid. It would be like rain. You know, condensation and then evaporation.
Mm-hmm.
Rain would be an example of condensation.
Okay, thank you.
And you get the condensation on like a cold glass of water that gets condensation on the outside.
Mm-hmm.
Yeah.
Or condensation on grass in the morning, dew, right?
Yeah.
Okay.
So solids, liquids, gases, and plasma differ from one another in the amount of energy that the particles have and the strength of the cohesive forces that hold the particles together. With that being said, I kind of wanted to say something. Just remember, as you're absorbing energy, the cohesion is always going to decrease. And as you're releasing energy, the cohesion is always going to increase. So that's the contrast between the two. Cohesion is a tendency of particles of the same kind to stick together. A solid has the lowest amount of energy because its particles are packed close together. Liquids have more energy than solids and gases. No, I'm sorry. Liquids have more energy than a solid, and gases have more energy than solids and liquids because the cohesive forces are weak. A substance can undergo a phase change if it is either absorbs or releases enough energy. Heating and cooling curves show the temperature of a substance as heat is constantly added or removed. The only time a substance experiences an increase or decrease in temperature is when it is entirely in one state of matter. As a substance changes states, its temperature remains constant. Any energy that is absorbed or released is used to change the way in which the particles interact with each other. Okay. We have number 1, solid to a liquid. So we know that is right here, melting. Number 2, liquid to a gas.
Evaporation.
Yep. Evaporation. Number 3, gas to a liquid.
Condensation.
Condensation.
Awesome.
Dami's
Yeah.
got that one. Dami's got that one. He knows now.
Liquid to a solid.
Freezing.
Okay, awesome. And these are the 2 kind of less known, but a solid to a gas.
Sublimation.
Yes. And a gas to a solid. Gonna be deposition. Yeah.
Deposition.
Miriam, someone had a question. What's the difference between vaporization and evaporation? I'm not sure that there is, but
Those are the same thing.
Okay.
The words are interchangeable. Yeah.
Okay.
Also, you might see Instead of vaporization, you might also see broiling. So that's another word that's kind of interchangeable.
What is it? Broiling?
Boiling, yeah. You'll see it on, yeah, on some of the questions.
Right. Okay.
Mhm. I also wanted to emphasize that this right here, this heating curve and cooling curve, you might want to sort of memorize it because you'll see that a lot of questions come from this heating curve and cooling curve right here. Yeah. So, okay.
So if you guys have the online course, what Miriam is looking at now is, we actually just added this into the course. It's a test bank that has every topic for every subject. And so you can study just those questions. So in the case of chemistry, we're going over states of matter. You're going to have, I think it's like 34 questions just on states of matter. And this would be for like A&P. You could study just 30 questions on cardiovascular, or and it's going to be like that for math, reading, English, and science. So if you have the course, that's where she's going to go over now. So let's go ahead and do that, Miriam.
Okay. So this is a really good question. Compare the melting points of 3 metals. So gold has 1063 Celsius, lead has 328 degrees Celsius, and mercury has negative 38.9 Celsius. Which of the following statements is true regarding intermolecular forces of these metals? Does anybody have an idea of what this could be?
Can you read those answer choices just for anybody who is either listening or may not be able to see it?
Oh, sure. The intermolecular forces are stronger between atoms of gold. The intermolecular forces are stronger between atoms of mercury. The intermolecular forces of these metals are stronger after they melt. The intermolecular forces of these metals get stronger as they are heated. So one thing I like to just remember is, I don't think we went over this, but the higher the boiling point or the melting point, the more the intermolecular connections are going to be, the forces are going to be much stronger.
Cool. So a bunch of people are saying A.
Yes. So with that being said, yes, it would be stronger with gold because it has the higher boiling point. I'm sorry, melting point. So it says, because gold has the highest melting point, it would take more energy to melt it than to melt lead or mercury. If a substance has a relatively high melting point, it is because the forces holding the particles together are relatively strong. Okay, let's move on to the second one. Okay, so when a sample of dry ice undergoes sublimation in a sealed bucket, what happens to its shape and its volume? So A says it retains its original shape and its original volume. B says it changes both its shape and its volume to fit those of the bucket. C says it retains its original shape, but its volume expands to fit that of the bucket. And D says it changes its shape to fit that of a bucket, but its volume does not change. Does anyone have any answers for that one?
Yeah, a bunch of people are saying B. And I have to say, dry ice like blows my mind. I used it for the first time the other week, and I don't understand how it works.
Yeah.
It's
Yeah.
just everything cold for a really long time,
Mhm.
and then it melted, and there was like nothing there. It just turned into what, a gas? Is that how that works?
Yeah, so that's one of the very cool sublimation examples.
Yeah, and we can do some cool science experiments with dry ice, right?
Yeah. So we know that's B because, like any other gas, it's going to take its shape and volume of the container it's in. In other words, the gas, the shape and volume is not constant, not fixed. So here it says, as a dry ice sublimes, it goes from a solid that has a fixed shape and volume to a gas, which takes both the shape and volume of its container. Okay. In which of the following phases are particles of a substance generally closest together?
Okay.
We have gas, B, we have liquid, C, we have plasma, and D, we have solid.
All right, so we've got some different answers here. We've got a few saying D or C, plasma, a few saying solid. Actually, just about everybody's on D, so I think
Okay.
I'm going to go with D.
So yeah, in a solid, particles have the least amount of energy and do not move as much as they do in other states of matter. The stronger cohesive forces between the particles keep them close together. So actually plasma, I think, did you say some people thought it was plasma, the answer?
I thought I saw a plasma, but it looks like most people had D, solid.
Okay, because plasma would be completely opposite. It would actually be the particles are further apart.
Okay.
Which of the following describes the sample that is boiling? A, the energy of the particle is increasing. The particles are getting closer together. C, the temperature of the substance is increasing. Or D, the cohesive forces between particles are getting stronger.
All right, so we've got A as a choice. We've got C. Most folks coming through is C, but we did have an A, so let's see what that is, and maybe we can also explain. A couple of people actually saying A, so there's a little confusion here. So let's also make sure we cover why A or C or B or D is or is not the right answer.
Okay, so when a substance is boiling, liquid particles gain energy and move further apart as they turn into a gas. So the answer C, the temperature of substance, the temperature is increasing, that's correct, but this kind of fits it more. The energy of the particles is increasing, because remember, as we go from a solid to a liquid and a liquid to a gas, you're going to be increasing in energy. Okay, everyone good on that one?
Miriam, someone was saying they weren't sure why the answer is not C.
I mean, C is correct, but A is more correct. It's kind of like if you've ever taken nursing tests where like
Nursing school answer.
oh sorry?
It's a classic nursing school answer. Like it's correct.
Yeah,
The other
like,
one's more correct.
pick which is the most correct. It's
Right.
like those.
Right. Okay. Yeah.
So
So
I guess we're talking about, this topic kind of is like about energy and the particles. That's why the A would be, fit it more.
Yeah. Okay.
And
So
again, just remember that as you're going from right to left on that graph on the chart, you're going to be increasing in energy. So you'll see as you're going from a liquid to a gas, because something's boiling, the energy is gonna increase.
Okay. So someone was asking, so when you add heat, you are increasing the energy?
Yes.
Right. Okay.
Like I said, this is like pretty much the introduction, and this is kind of the foundation. So let's say, for example, in a couple of weeks, if we do like balancing chemical equations and I talk about gases, I just want to make sure everybody knows what I'm talking about. So that's why like this stuff, although it may not be on the exam, you are going to need to really know it as a foundation for the next topics in chemistry. Okay. So in which of the following situation does helium have the greatest amount of energy? So this kind of relates to what I was saying before. Remember, as you go from left to right on that chart, you're going to increase in energy. So A is helium is liquid at temperatures below -270 Celsius. B is helium gas is used to blow up a birthday balloon. C is helium is used in yellow-orange neon lights in plasma form. Helium is stored as a liquid for use as a coolant in space applications. So which form would have the most energy? We have a gas, liquid, plasma.
So a few people saying C, someone said B, and the reason being because gas has the highest energy.
Okay.
And we're between C and B, so a little bit of a debate there.
Okay, so the answer is C. It would be in plasma. I know we didn't go through this too much. Out of solid, liquid, and gas, the most common states of matter, yes, gas does have the most energy, but plasma has even more energy in it. It's just kind of one of the least common ones.
I'm
Right here.
confused on the yellow orange neon lights. What do they mean by that? That's why I didn't think it was the answer.
Yeah, so the yellow, orange neon lights, honestly, that's just a bunch of like filler. It's just a bunch of like, you don't really have to pay attention to that. You really just have to pay attention. Is it in a gas, a liquid, or plasma form? So you see how helium in the first one is in liquid form, the second one it's in gas, the D is in liquid. So this is in plasma form, and plasma is going to have overall the most energy in that state of matter.
Yeah, someone just asked if plasma has more energy than gas, and so I think you just answered that with a yes.
Mm-hmm. So remember, the most common states of matter are solid, liquid, and gas, right? Solid has the least, liquid has more, gas has the most, but then there's plasma, and plasma is just not really that common, but it has the greatest amount of energy. Okay, a stick of butter is melted in a dish in the microwave. After it melts, which of the following states describes the butter? A, it has both the shape and volume of the dish. B, it has the shape but not the volume of the dish. C, it has the volume but not the shape of the dish. And D, it has neither the shape nor the volume of the dish.
So we've got some answer choice C, people are saying, a few C's. And someone's saying D.
So
Most are going with C, though. Someone says A, so we're a little bit across the board here.
Okay. So I'll click C since most people are going with C. So it says incorrect. It says as the butter melts, it goes from solid to a liquid, which takes the shape, which takes the shape, but not the volume of its container. So basically it's saying that the dish is melting. The butter is melting. So if it's in melting, it's in liquid form. And if you remember liquid form, it takes the shape of the container, but the volume stays constant. So that's why the answer is it has the shape, but not the volume of the dish.
Okay, so that might be confusing for some people. I know Katie's asking, what do you mean by not take up the volume of the dish?
Okay, so volume stays constant because volume is just the amount of space that something takes up, if that makes any sense. Like the definition of volume is just the amount of space that something takes up. So a stick of butter, whether it's in its solid form or melted, it's gonna take up the same volume in the atmosphere either way. So volume
You don't get more of it whether it's melted or solid.
Yeah, but the shape will
Change.
change.
Right.
Does that make any sense?
Yes.
Okay.
Yep.
During which of the following phase changes will the cohesion between the particles in a substance decrease? So A is condensation, B is deposition, C is freezing, and 4 is vaporization. So let's see. Okay. Does anybody have any ideas?
So we've got a ACA.
ACA. Okay. So remember I mentioned that, so it says, during which of the following phase changes will the cohesion between the particles in a substance decrease? So remember I said when something is absorbing energy, the cohesion is going to decrease. So if you take a look at like a heating curve, that's going to be when the cohesion decreases. So it'll either be vaporization or melting.
Okay, yeah, a lot of people are saying D.
Yeah. So if the cohesion between particles decreases, then the particles must be undergoing a phase change that allows particles to move further apart. This happens when a substance vaporizes and turns from liquid to gas. So I just want to show you one more time this this heating and cooling curve. If you guys just maybe Google it or something, and take some time to really look at this heating and cooling curve, it'll really help you understand absorbing energy and cohesion if it increases or decreases. Okay, let me repeat that. In a cooling curve, particles are going to release energy and cohesion is going to increase. In contrast, in a heating curve, your particles are going to be absorbing energy and cohesion is going to decrease. Did everybody get that? So that's just like a general rule you can kind of write down like next to the heating curve and cooling curve. And I think that'll really help you absorb the information and kind of like relate it to each other. Yeah, so if you kind of remember those things and relate them to this heating and cooling curve, you can really answer a lot of questions just by kind of memorizing that or understanding that.
So I think that's it. So let's all give it up for Miriam. We really appreciate you and your time.
Yeah, if you guys think of any other questions and you guys are studying later on, don't hesitate to ask me on my Instagram or my YouTube, and I'll get back to you.
Yeah, you guys can leave comments on her YouTube. I don't think she's on Facebook as much. She actually just made a profile so that she could come into our group. But if you are on there at all, you can throw out questions and maybe she can check them out there. But Miriam, yeah, thank you very much for your time. We're getting a lot of thank yous. So people are very appreciative, as am I. So I think that's it. So I hope everybody has a good evening, and hopefully these kind of times work for everybody. I know there's a lot of East Coast and West Coast folks, so we try and kind of do this so it's a little late for East Coast, maybe early for West Coast, but hopefully it all works. I know Randy's asking about the subscription to the Smart Edition Academy. How long is the subscription? So it doesn't expire. It's a one-time cost, and you have it for as long as you need it, so it never expires. Tisha is asking how does she know if she has it. I will get with you, Letitia, in just a second so I can help you out with that. But for everybody else, I think we're good to go. We'll do some more of these. We have another session coming up next week for anatomy and physiology. Post in the Facebook group if you are in there. We have not decided which system we're going to go over for A&P. So if there's one that you want more help with, make a post in the Facebook group and let us know kind of what you need help with or what you're looking for. I'm already seeing Christy say cardiovascular. Do that, and we'll make a post asking people what they want to see. So we'll kind of go from there. Looks like we have one more question. Brittany, go ahead.
Hi. So I wanted to know, like, if you purchased the course today, like previous videos that you've made with similar stuff like you did today, like, would we have access to it?
Yeah, absolutely. So you have access to, all the videos like these tutoring sessions, they're on YouTube and in the Facebook group after, but in the actual course itself, there's about 100 video lessons within the course. And maybe I can share my screen for a second. I just, and if you guys need to run, you can, but I'll just share my screen for just a sec. I'll show you kind of what you would be looking at. So this is the course here, and kind of what you'll see is basically all the different sections, and you'd have like reading with the different lesson content, and you'll have the lessons, and then at the end of each kind of lesson module, there's a chapter test. So there's lots and lots of practice questions in the actual lesson modules, but also at the end of each of these sections, you'll kind of have like a chapter test. And if we're in math, we kind of break it out by the different areas. And if you clicked into any of these lessons, you will see videos, video lessons. And actually for the math ones, if you guys are familiar with Brandon Kraft, he did all the math videos for us. If you're not familiar with Brandon Kraft for math, you guys should definitely check him out. He is really, really fantastic. We work together all the time, so you guys should check him out but he has like a website, his own Facebook group, tons of stuff. But I'm gonna show you guys so basically you get the idea. There's video lessons for every topic, whether it's science, math, English reading. So yeah, that's the long answer to your question. There are videos for everything, so you'd have access to that. And then aside from all these lesson modules, there is 8 practice tests. Once we get here, so there's 8 full-length practice tests that are timed, very similar to the actual exam. I think someone asked in the messages if the practice tests were similar, and they definitely are. And we've worked probably over the past 4 years to get these practice tests to be very, very similar in terms of the number of questions, kind of the format of the questions, the topics they cover, and the fact that they're timed and just kind of very realistic to the actual test. So you have those 8 practice tests, and we put in a bonus test recently with more chemistry and biology. And then you have a practice test question bank where we break everything out. So anatomy and physiology, say you would be able to do 30 questions just on the respiratory system. And, it's a little different. This one has 33, but you'd be able to do just respiratory system questions. And the best way to use this course is to really anything you have. If you have another study guide or a book or some other course from any other company, the best thing you guys can really do is take practice tests and try and identify what your weaknesses are. And practice tests should have this. I know ours does. We have a scored report. And at the end of the scored report, it breaks down all the questions you took, say, in the science section, and it'll tell you by topic. If there was a states of matter question, it'll let you know that was a states of matter question. And you can kind of start to see what questions you're getting right and wrong. And if you see you answered, I don't know, all the cardiovascular questions wrong, that's going to be one of your weak areas that you want to focus on. That's how you're going to get your score up the fastest, by focusing on those areas. And then you can go over here to anatomy and physiology and just study cardiovascular questions. You don't need to take a whole practice question with everything, whole practice test with everything. You can just take the cardiovascular system. So that's something actually new we added about a month ago. So we're pretty excited about that. A lot of good feedback. People find it very helpful. And then you'll also have flashcards. So these flashcards are also within the actual lesson modules themselves, but we also put them here. And so you'd be able to go through and do, there's 259 A&P flashcards, the life and physical science, you've got 58 chemistry flashcards. So you can kind of go through and do all these flashcards. So that's just a little, tour of the course for whoever's interested. But yeah, it's just lots and lots of practice. Like, I don't know, there's like 1,300 practice questions, flashcards, all that stuff. So hopefully that's something that can help you guys out. And if you don't have it yet, check it out. Kalani said she loves the course, so we appreciate that. We put a lot of work into it, so we hope you guys enjoy it. So aside from that, it looks like I think we've answered all the questions, and we should be good to go. Guys, keep an eye out for the announcement of the next group tutoring session, which will be on A&P with Nurse Melissa next week, probably Tuesday or Wednesday. So we'll announce that probably in the next day or so. Other than that, let's give it up for Miriam. Appreciate it. Everybody's clapping. Okay, cool. All right, guys.
For being here.
All right, everybody have a great night. We'll see you soon.
Good night.
Bye.